Hey guys, so we are still learning about matter. Today's essential question is, how do particles behave in the four states of matter? All right, so our objective today is that you will be able to distinguish between the states of matter by analyzing the kinetic molecular theory and predicting phase changes by analyzing how thermal energy impacts molecular movement. All right, so the kinetic molecular theory states that the kinetic energy, which is just energy in motion, of the particles of matter increases as temperature increases. That's a lot of big words, but you already know what that means. For example, when ice melts into water, the particles move faster. You know that. Okay, so everyone has eaten a popsicle before, and you know a popsicle will melt. So when a popsicle is melting, it is changing from a solid state of matter to a liquid state of matter. And that is what a phase change is, when you change from one state of matter to another. A phase change, also known as changes in state, is what we're going to look at today. We're only going to focus on 4 phase changes or changes in state. And the 4 that we're going to focus on is condensation, which is when a gas turns into a liquid; evaporation, when a liquid turns into a gas; freezing, when a liquid turns into a solid; and melting, when a solid turns into a liquid. You've seen all of these happen on a regular basis, but now we're going to look at it scientifically and look at what's happening with the particles and how these phase changes occur. Okay, so we know that particles in liquids have more energy than particles in solids. A particle in a gas has even more energy than a particle in a liquid. Therefore, to change a substance from one state to another, a phase change, you must add or remove thermal, that's just heat, energy. Once again, in order to change a substance from one state of matter to another, or in order for you to have a phase change, you must add or remove thermal, which is just heat, energy. So if you look down here, this is just the diagram of a phase change, okay? If we focus on gas to plasma, you see gas is changing phases to plasma, and the reason why is because we have added energy. Remember, we're thinking of energy as heat. All right, so what happens when you are melting something or a solid is turning into a liquid? You are adding energy to a solid to increase the temperature of the solid. As the temperature increases, the particles of the solid moves faster. When a certain temperature is reached, the solid will melt. The temperature at which a substance changes from a solid to a liquid is the melting point of that substance. All right, let's check for understanding. What type of property is melting? And if you said it is a physical property, bravo to you. It is physical because the chemical makeup is still the same and no new substance has been created. Freezing occurs when a liquid turns into a solid. You are removing energy or heat. You are removing energy from a liquid, which is decreasing the temperature, and it will cause the particles to slow down and begin locking into place. When a certain temperature is reached, the liquid will freeze. Freezing is the reverse of melting. Thus, freezing and melting occur at the same temperature. One adds energy and one removes energy. Boiling and evaporating is what happens when a liquid turns into a gas. As energy is added to a liquid, you are increasing the temperature. Remember, energy is heat. Particles throughout the liquid move faster. When particles move fast enough to break away from other particles, they evaporate and become a gas. And then you have condensing, which is when a gas turns into a liquid. Condensation is the change of state from a gas to a liquid. You are removing energy, so you're decreasing the temperature from a gas, which will cause the particles to slow down. When the attraction between the particles overcomes their motion, the particles clump together to form condensation. All right, so energy and changes in state. When you are going or changing state from a solid to a liquid, you are adding energy. When you are changing state or having a phase change from a liquid to a gas, you are adding energy. When you have the phase change of a gas to a liquid, you are removing energy. And when you have a phase change of a liquid to a solid, you are also removing energy. Adding energy can also be viewed as adding or removing heat. Remember, when we think about energy, we are thinking about heat, all right? So if a gas is turning into a liquid, heat is being released. If a liquid is turning into a gas, it is being absorbed, etc. And it's okay if you're a little confused. We'll get more into this in class. There is a relationship between energy, temperature, and particle movement. When most substances lose or gain energy, heat, one of the two things happens to the substance. Its temperature changes or its state changes. The temperature of a substance is related to the speed of the substance particles. If you add or increase the temperature, the speed of the particles increases. If you decrease temperature, the speed of the particles decreases. All right, that is it. All right, so this is a phase change diagram, okay? And what you are seeing is a temperature change. As you can tell, as the temperature increases, a phase change happens. Now, there's a blue line that says phase change, and if you can see, this blue line is flat. And the reason this blue line is flat is saying that the temperature is staying the same. When you have a phase change, when it's changing from one state of matter to another, the temperature stays the same, okay? So if you were melting ice and you had that ice water mixture as it's like turning into a liquid, that phase change is occurring, the temperature stays exactly the same. Once it becomes a full liquid, as you can tell, the temperature changes again. And then when that liquid is in that in-between phase of being a liquid and also kind of a gas, that's when a phase change occurs. The temperature stays exactly the same. Once it turns fully into a gas, the temperature increases again. So what you need to take away from this is when a phase change is occurring, the temperature stays the same. All right? Let's wrap it up. A solid, tightly packed in a regular pattern. The particles vibrate, but they don't move from place to place. In a liquid, they are close together with no regular arrangement. They slide past each other. In a gas, the particles are well separated with no regular arrangement. They move freely and at high speeds. And then there is a plasma, which has no definite volume or shape, and it's composed of electrically charged particles. And y'all, that's it.